Welcome to another CATIA V5 video. We're going to take a look at combining Imagine and Shape workflow with Generative Shape Design to design the following plastic bottle. So let's get started. I'm going to close this and I will start a new shape. I will go directly within Sketch Tracer. As we can see, we have a new product defined over here. Now, since the reference is a side view, I'm gonna go over here and I will jump directly within the right view. We see the compass orientation updated. That means I can load the reference, which I can enable over here, create an immersive sketch. I have the reference position over here on the desktop, so I'm gonna load this. And we see that we're gonna have the model loaded. If for some reason you have a warning regarding the visibility, that is because you are currently either in shading with edges or let's say shading with edges without smooth, and that means you won't be able to view materials. And in CATIA, to view references, you need to be within the view with shading with materials. So this is one of the drawbacks. Other CAD solutions don't have this problem for visualization, such as SolidWorks or Fusion 360, but keep in mind that if you receive that warning, you need to enable shading with materials. And afterwards, we're gonna have the sketch loaded. We have over here the type of view. As we can see, we have a conical view and a cylindrical view, but we are not gonna use those. We just need to calibrate the image. That means we're gonna have to move over here. We have the origin. I'm gonna position this at the bottom of our shape, so somewhere over here. I can even go closer to that point. And now, using the outline interior profile, I'm going to roughly add that reference. So I know that from the base all the way to the top of the plastic recipient, I can define the height over here. So in this case, currently this is set to 173 millimeters. I will click on that and I will type in 200 millimeters. And as soon as I will click OK, since the software will respect the aspect ratio of the photo, we're going to see that we're going to have minus 77 over here. It's not a problem if it's with minus, we can keep it like that. So we're just going to click on OK, and we're going to have within the application, within painting gallery, the painting added, which is the side view. And now we can start adding the part. So in this case, I will select the product 1, insert. I want to insert a new part. Now, with this newly added part, I'm gonna double click over here on part 1. And as we can see, this will swap me directly to Generative Shape Design, because this is the last workbench where I worked. So I will go to Shape, and we want to start with Imagine and Shape to draw the overall shape of the plastic bottle. And within Imagine and Shape, I will go within the right view. I'm going to select the Z and X plane, and I will start the shape with a cylinder over here. So we see the cylinder shape. This will be rotated at 90 degrees since I selected that plane, but that shouldn't be any problem. We can go over here, all element selection, and we can go to the rotation, and we can add and manipulate the rotation over here. So in this case, you want to have this rotated not on the y-axis. As we can see, the axes are over here. On the x-axis, 90 degrees. That will rotate the cylinder. Now, since the orientation of the cylinder is properly aligned to the view, we can just put this within position. That means I'm going to go over here, all element selection, go for translation, and I'm going to position the cylinder over here. Now, if you want to see through our shape, we're going to add an opacity for this. So I'm going to press space to leave that edit mode for the cylinder. And over here within part 1, we see at the top we can define the opacity of the part. If for some reason you don't have the graphic properties enabled, let's say that this has been closed, you can go somewhere on the toolbar, for example over here or where you have an open space, and you can enable the graphic properties. And this should pop up right where it was last time. So in my case it was positioned over here. If I want to dock it, I will just grab it and I can move it over there, as we can see. And with this selected, I'm gonna select the whole part 1 over here, and I'm gonna make everything at 50%. We're gonna see that see-through opacity through the model. And now we just need to define the starting shape for this. So I'm gonna select, in this case, the subdivision surface. I'm gonna press space to go within edit mode. With the selection vertex over here, I'm gonna grab the top vertices and I'm gonna move them over here at the top. And now I will make use of face cutting in order to add additional faces. So with the face cut selected, left click once on the subdivision, and we're gonna do 3 cuts over here. So on the horizontal axis we're gonna have 3 cuts. That means 4 surfaces, and I will go with 6 cuts for the vertical axis. Afterwards we can close the face cutting, and now we just need to drag within position the points. That means that I'm gonna zoom in closer to the shape. I will press space to go within edit mode. I will hold down shift so I do a trap selection, and with the move tool enabled over here for the translation, I'm gonna start to move those within position. Now we see that for the reference, the hand drawing sketch had over here a spline. We're gonna make this flat on the bottom. So I'm gonna just ignore that, and our final shape will be flat. I will slightly move all those points in order to better follow that outline. If you're moving a point and afterwards the adjacent point will also be affected, you can go back and reposition that. So holding down shift, I'll do various trap selections. In this case I can add additional points over here, but we're gonna see if we're gonna do that, because we roughly wanna have that that shape defined. At the top I will slightly move those points so that this point can be better positioned over there on the sketch. Over here at the top I will select this one, slightly move it backwards to the back, and over here I'm gonna move this a little bit to the left. As you can see, I only move one vertex over here, so I will press undo because I need to have that corrected. Again, undo once again, and now with both points overlapped, hold down shift, do that grab trap selection, as it is called within CATIA. We see shift key trap selection, and have those realigned. We're going to define the top surface over here as well. So we're going to try to follow that spline at the top. Okay, and we still have this side to fix, which means that the same workflow will apply over here. Various traps in order to move the points according to the drawing. Okay, for this point I will slightly move it over here. Okay, so let's say that roughly we managed to follow that. Now if we rotate, I'm gonna see that the plastic container will be quite wide in this case. So we're gonna scale it on that axis. That means with the object selected, go to all element selection. Afterwards, the scaling CATIA is called affinity and is located over here. We see that the axis will be the z-axis, so we can either move this, and we're going to see how that will reposition, or if you want to work with numeric values, you can open the addition table over here, and we're going to see in our case this will be the z-axis. Let's say that we want to have this at 50 millimeters. And we can also round up the other axis if you want to, but in that case it will no longer be that tight to the outline that we position. So we can keep it either like this, or we can round it up, for example 283 in this case. I'm going to click OK. We see that it's slightly shrinked up a little bit. So this will be that shape that we're gonna start and cut. So this was the Imagine and Shape section of this workflow. Therefore I will jump within Generative Shape Design, and over here there are multiple workflows. I can define a sketch where I'm gonna position all those splines that will define this, and afterwards I will just copy each one and have it extruded for the split. So let's do that approach. That means that within the Z and X plane, I'm going to define a new sketch, and over here I will make use of a spline to follow the top of that section. So we see the spline over here. I will keep the spline only defined by 3 points in this case, because I don't want it to be quite curved. So if you're just gonna use 3 splines, you're gonna see that the profile will look like this. And afterwards I will slightly adjust those points. For example, if I would use something with multiple points, you're gonna see that it's a little bit harder to have those smooth splines. So in this case less is better for splines. Now for the second one we can make use of an offset. Therefore I will use this selection and I will go with an offset. If you want to add a specific value, we see at the top the offset within sketch tools. Now it's 2.7. I'm just gonna tab until I'm gonna reach it over there, and I will type in 3 millimeters. And we see that this follows that cutout. And now using the same spline tool, I'm gonna create this shape on the main body of the plastic bottle. So I will position additional points. At the end you can press escape to have that closed. Not closed, but finished, because a closed spline is something differently. Over here I'm not going to use the offset, since those are not defined using an offset. As you can see, these are the sketches that we're going to cut. And now I will define a new plane, and I will select the top spline, and I will have this projected using the project 3D element. That means that CATIA will have that sketch defined in yellow, and as you can see we have that visible over here. And with that spline we're gonna go and have that extruded so we can do the split. So before I'm gonna split this, I will also wanna split the bottle in half. So I will cancel this. I will go back to the Z and X plane, and I will create a rectangle that will be bigger than the subdivision, so something like this. You don't have to add any specific values. It's important that this rectangle will be larger than our shape. In this case it is larger, therefore we can use the fill in order to have that closed. And now with this newly defined surface, we're gonna trim in half our plastic bottle. Therefore I will use the split. In this case we have element to cut the subdivision, the cutting element will be the fill. And we're gonna see that we're gonna have just half of the bottle. We can hide the fill since we are no longer gonna use that. We can also hide the sketch used for the fill. And now with the next, let's say previous sketch, we can have this extruded. I'm gonna go with this, in this case 40 millimeters. Again, it's important that the spline is extrapolated outside of the original shape, as we can see over here. Therefore CATIA will be able to do the split in this case. So I'll go for split, element to cut. In this case, if you're gonna see, I'm gonna select over here, and CATIA will make with orange split 1, because this is no longer considered to be subdivision surface 1, since this is considered to be split 1, since we had that cut on the middle. I'm gonna keep both sides. That means that both the top surface and the bottom will be kept. So we see cutting element, we can go and press OK, and we're gonna have that defined over there. I'm gonna remove the opacity since we're gonna be able to better see that that shape. So we see the shape, we see the extrude, which we can now hide. We see sketch 2, which again we can hide. And this will be the half recipient of this plastic bottle. We're gonna do the following cut. So go back to the plane, Z and X plane, and over here I'm just gonna show sketch 2 in order to project the offsetted spline. So I double click there by mistake. I will just select that, but we need to be at the sketch level, have that selected. My mouse is let's say quite buggy with a double click, so sometimes I don't want to double click, but the mouse does that. So we have the sketch defined, we can hide sketch 1, and again this will be the same workflow, which is an extrude, and with that extrude we're gonna do a split. So element to cut will be the bottom surface over here, cutting element will be the newly extruded section, and we're gonna see that in this case I don't want to keep both sides. So if I'm gonna click over here, other side, we're gonna see that that will be the remaining element. So in this case the other side will be the bottom one, and always the selected one will be kept and the other removed. In this case, as you can see, this will be those two surfaces. The same workflow gonna be applied moving further along with the design. So we're gonna have this one. I'm just gonna project this over here so we can make use of that cut. With this sketch selected, go to extrude. The same 40 millimeters should be fine. And in this case again we're gonna do a split, element to cut, cutting element, and again we're gonna keep both sides in this case, and we can hide that. And we're gonna see how we're gonna have split 5, which is this one, and we're gonna also have split 6, which is the smaller interior one. And we're gonna do the same for the final sketch, which is this one. Have that projected. We can now hide sketch 1 because we use all of those. And with this I'm gonna do the same extrude, the same split. So we have the element to cut, we have the cutting element, and in this case we want to have that removed. So we don't gonna check that keep both sides because we don't want that middle section. Hide that. We can also hide the sketches. So sketch 5 and 6 in my case, I'm gonna hide those. And now we're gonna need to define an offset for this middle element over here, so it's called split 7. You're gonna find underneath surfaces, we're gonna have the offset. So we have the surface, in this case no selection, I will select split 7 and I will select the offset to be 2 millimeters. I'm gonna click OK and see if that went on the right direction. So we see this is offset 1 within the interior, and this was the original surface. So by using 2 was okay. We don't have to go into reverse. If you're gonna select reverse, in this case you're gonna see that it will go outside our initial design. So we want it to be inwards, the offset. And now I can hide this split 7 because the final mesh will be this one, the interior one. And we can start joining those surfaces. So to do that, we're going to make a combination of sweeps over here. But before we can use that, we're also going to need to define some points and borders. So let's do that. I'm going to go over here on wireframe, and we're going to have the first point added right over here on the corner. The second point underneath that on the other surface, the yellow surface. And now we need to define a profile that will be used by the sweep command. So the same plane, Z and X plane. I will zoom in over here, and I will make use of a 3-point arc. So I will select the first point, the second point. Afterwards I will define that radius. And now select those points, so the endpoints of the 3-point arc, the points that we defined previously, and make those to be coincident. And also need to define the radius. So in this case, let's say that we're gonna go with a radius of 2.5. So we have that profile ready for the sweep, but we also need the guidelines. In order to obtain the guidelines, we're gonna use boundary, which we can find over here, boundary, underneath operation. If for some reason you are not able to select this, keep in mind that you can go at the top, insert, you're gonna find all those features over here. So operations, we're gonna have that boundary. So with the boundary selected, we see that we need to select the surface edge. So in this case, I know that this is the surface edge. CATIA will select all the boundary for this, and we need to use the limit in order to define the sweep guideline. So the first point will be over here, and the second point will be over here where the sweep will end. We have one boundary defined, the same workflow for the bottom one, with the limit, limit 1 and limit 2. If this will go the other direction, you can use the arrow in order to swap the direction. And now we see that this is properly defined. Therefore, we can use the sweep. So we see over here the feature is called sweep, and we have swept surface definition. So the subtype for this one will be with 2 guide curves. And we have the profile. The profile is the 3-point arc that we previously generated. Curve 1, you can select either the top or the bottom. And we also need to define the anchor. So the anchor for the first selection was the top one and the bottom one. If you're gonna hit preview, you're gonna see how that sweep will follow along. We can now join the bottom surfaces. So this we want to keep it as the top of our component. So I'm just gonna merge those two at the bottom, and afterwards you can hide the boundaries. You can also hide the points because we're no longer going to use those. And the same workflow we're gonna use over here once again. So we have those points, point, afterwards a boundary with the specific limit, which is this one, and we have the secondary boundary, which will be this one. So we just need to have that reversed because we want to follow along over there. And now we need a new sketch. In this case, again, I will make use of a 3-point arc. Roughly position those close to that. The same workflow with coincidence. This is important. If you don't have coincidence in Generative Shape Design, CATIA won't be able to have that drawn. In this case, the radius I will go with something larger, like 5. You're gonna see that with 5 at the top it will be quite close over here, so I will slightly change that. Okay, I need to go back. So see that currently I'm using sketch tracer because I double click on the image on the back. Therefore I need to go back to part 1 and to the sketch over here. Let's see if I'm gonna make this 6. This will no longer be that tight at the top, so in this case it will be better. Keep it at 6 and start defining the sweep. The same with 2 guides. So we have the profile, we have the top, the bottom, we have the anchor points, and we can hit preview. You can see that in this case we see that faces has a small edge. It may lead to an error. Let's see if I can have this expanded. In the following operation, clean up data. Okay, I will slightly check to see if we have any problems. If for some reason there are some small patches, that's something that the join feature will deal with. So we see that it was a warning, but I don't see any problem with the surface, so we can have that defined. We see that we have no warning on the sweep over here, therefore I will consider that we can use it. Over here there are some small white points in some preview mode, so let's use join to join the previously join, which was join 1, have it merge with the sweep and the offset, and we have the merging distance over here. I'm going to type in 0.1, and that should deal with any small gaps that the surface should have over there. As we can see, there aren't any, let's say, problems. Okay, so now I can hide the painting, and the next step will be to have this mirrored. We see at the top those surface. So let's have this mirrored. That means I'm gonna mirror them separately, so I'm gonna keep the cap differently. As we can see, this is the join, so I'm gonna mirror join 1, have that selected, go over here, you're gonna find symmetry. The reference will be the plane, and now I'm gonna join those two, so this will be the base. You can also rename it. Over here underneath properties, I'm gonna call this the base of the bottle. This will be the the cap, you can select over here and you can right click and center graph. That will move the graph to the location of this. So this is split tool. Have that with symmetry and have that merged, because now this is a different color. After the merge, the color should be uniform. And now we know that this is the cap. I'm gonna call it cap. And we can add some fillets over here to have this more stylized. We can make use of the shape fillet tool over here. We also have different fillet types over here. So in this case, maybe edge fillet will be better than shape fillet. So let's go with edge fillet. Since it's called edge fillet, we're going to select the edge. As we can see, for the top with 5 millimeters radius, this will be the preview. So I would prefer it to be rounded like that. So I'm gonna click OK. I'm gonna use the same shape fillet over here. Since this is not merged with this one, we can't add that fillet over there. But over here on the bottom area, we can define a smaller radius, 0.5. Since these are merged, this can go all the way along this. Or maybe 0.5 is quite small, so have that increase to something like 2 millimeters. That should be a little bit better. The same shape fillet can be added over here with a larger radius. With 5, we're gonna see it will look like this. I'm gonna add another one over here. As you can see, for the next section, if I will go with that one, I'm gonna swap over here to shading with edges in order to better see those. If I will select this with tangency, it will only propagate all the way over here. So over here the tangency is no longer in action. So click the second selection over here. We're gonna have an object to fillet 2, and that should deal with that. We see over here, since those are not fully tangent, we have a small problem over there. But if you're gonna click OK, let's see, we're gonna have those twisted surfaces over there. I'm really curious why we have that, so let's try to clean up that. So this is an area that was offset. So we have this offset that was set to 2 millimeters. And this was cut using a spline. So let's search for that spline, which is this one, but this is a projected one. We have all the control over here. And for some reason, somewhere over here, we don't have that tangency. I will just slightly move this point. And CATIA should now update. We see that it is with red. We can go with local update and see if that managed to do anything. We have the shape, and we see over here we have the tangency, but this is what we had previously. And over here the tangency will be lost. So somewhere over here in this point, CATIA decided not to have that propagated. So we have now only this section at the top. I'm gonna try and use a shape fillet in this case. As you can see, this is bitangent and tritangent, so in this case it won't be useful. So let's take a look if we can use a styling fillet. But in this case it won't be that. So we still need to go with this one, but we're gonna make use of a variable fillet. So let's take a look at this one. So we're gonna have that selected, variable with 5 millimeters, and again we have some warnings over here. Yes, I will just leave that unfilleted. Let's take a look at how it looks with shading with materials. Okay, so we're just gonna keep that without a fillet, since for some reason that spline after an offset decided that it's no longer tangent over there. And let's just add a fillet at the bottom where it should work as intended. As we can see, we have that propagation fully defined, and we can have this for 5 millimeters as well. And we see that we have a warning over here, ribbon computation, please check the curvature with curvature analysis. Over here we're gonna still have that problem, even that with curvature analysis, with the zebra overlap on top. Let's see if we can add thickness. We're gonna define the thickness for this part now, since I see that the video is already 36 minutes long. So go to thick surface, select the cap. I'm gonna make this 1 millimeter and a half on the exterior, and for this I'm just gonna make it 1.3, so I want the cap to be a little bit larger, but again towards the outside of the part. And we're gonna have that defined over here. If I will go with 1.5, those surfaces should be merged over here. As you can see, we're gonna have that gap between the cap and our bottle. Now, since this is imaginary shape, one of the main advantages is that we can always decide and we can change the main body. So for example, if now I want this to be wider, I can just select this, go to the affinity, and I can increase this on the z-axis. So as you can see, I made this narrow quite a lot intentionally, and if I'm gonna have this updated, you're gonna see that the split will no longer work, and this is because the extrude is not long enough. So keep that in mind, that if you want to have those extended, now I should go within each extrude, and we can see that this only cuts 40 millimeters. So I will go 140 just to be sure. But now we're gonna have the same problem with all of those. So I'm just gonna rapidly go and have those adjusted. So it's a good idea to have that extrude larger by default if you want to make some changes later along the way. We see that all those are waiting for an update. I'm gonna click update all, and yeah, those surfaces have been redrawn. As you can see, we're gonna have that wide bottle process by CATIA, and the same will be if you want to have this some elements selected and rotated. That's the let's say the beauty of imaginary shape, is that you can do that. You can have those selected, rotated, translated, and so on if you want to change the shape. So for some reason I would want the bottle to be shaped like that, and I don't want it to be that wide, so make it a little bit narrower. Press escape at the end, do an update, and we're gonna see that now those points will no longer be properly positioned. Since I rotated that, we have this point which is just standing in mid-air. So keep that in mind. If you also want to rotate some of the elements that were defined over there will also be, let's say, not that easy to rescale. But if I want to have that rescaled without the rotation, we're gonna see that within the update we don't gonna have any problems. And at the end, if you want to, you can use some of the materials over here. You can have those drag and dropped onto the part, and you can do the final render afterwards within Photo Studio. Or I highly recommend that you have this exported as a step file and you go within a different software, either Keyshot or Blender, since those are a lot better for rendering than CATIA. CATIA is mainly a computer-aided design software, so we should use it mainly for that. Okay, so I hope you find this video useful. I'm gonna position a similar video over here to the left and a subscribe button to the right. Thanks for watching.